Hello student, this video lecture is prepared for the heat transfer subject. I will discuss the unit number 5, that is known as the heat exchange equipments. And in last lecture I had discussed how to give the names depending upon their uses for the heat exchangers. Then I had discussed double pipe heat exchangers, what are the advantages and disadvantages of double pipe heat exchangers. Then the most common type of the heat exchanger is shell and tube heat exchangers, that we have already discussed. And in today's lecture we will discuss what are the parts of shell and tube heat exchangers. So let us start the lecture. So in last lecture I have discussed that what is meant by shell and tube heat exchanger. It consists of number of parallel tubes, the ends of which are mounted in a tube sheet, and the entire tube bundle is enclosed in a close fitting cylindrical shell. Okay, so we are having parallel tubes. These tubes are mounted or fixed in a tube sheet, and these tubes, which is called a tube bundle, is enclosed, that means it is fitted in a cylindrical shell, and one fluid is flowing through that tubes is called a tube side fluid, and another is from the outside of the tubes is called a shell side fluids. So first first important part is the shell. So shell, what is meant by shell of the heat exchanger? It is a cylindrical casing, that means outer part of that heat exchanger through which one of the fluid flows in a one or more passes. So generally these shells are made from the carbon steel. So material of construction of this shell is carbon steel, and these cylinders are cut into the required length, means according to their application, from the standard pipe up to 60 centimeter diameter, or it may be fabricated from the plate. Okay, so these cylinders are made by taking a direct pipe, or we can fabricate from the plate. And what is the material of construction? Maybe carbon steel. The minimum thickness of the shell is vary from 5 mm to 11 mm depending upon the diameter. So the generally thickness is depend upon the diameter. So common thickness which is used in a chemical industry is 5 mm to 11 mm. So I will show the figure of the shell. So if we look at this first figure or photo, so this is called a shell. So outer part is called a shell, or it is the outer cylindrical casing. So if we look from inside, so this part is called a shell. So this part, outer part is called a shell. The next part is the tubes. So these tubes are used generally in a heat exchangers are standard, that means their length, diameter, thickness are standard. So diameter of that tubes may be vary from 6 mm to 40 mm, and 19 mm to 25 mm are very common diameter, outside diameter, and the length of the tube is 0.5, 2.5, 3 or 4 or 5 or 6 meters. So depending upon your heat transfer load or calculation, you can take this length. And the thickness, that means thickness of that tube, is generally expressed in terms of Birmingham wire gauge. Birmingham wire gauge. In short, it is called BWG, capital BWG. So this thickness is depend upon material of construction, that means how that tubes are made or from which material that tubes are made, that is called a material of construction. And the diameter, so we already discussed, the diameter is kept between these two, 6 mm to 40 mm. And this thickness is given in this BWG number, or BWG is nothing but it is just a number, suppose 10, 12. So these are the numbers, and these numbers is having particular diameters, for example 19 or 25 millimeters. So if we look at the data book of the heat exchangers, you may find the table like this: wall thickness, in internal diameter in inches, outer diameter in inches. So this wall thickness is like 10, there may be one internal diameter, outer diameter, then 12, then there may be internal diameter, outer diameter. So like this we have obtained the data for the tubes, and these tubes are placed in a tube bundle inside the shell, either rolled or welded to the tube chute. That means these tubes are collected as a tube bundles, and then these tubes are rolled or welded. That means just you have to press that tubes in that tube sheet. We will discuss what is meant by tube sheet, or weld to that tube sheets. The tube side fluid first enter in a header, that means there is bonnet is provided or channel is provided through the nozzle, and then it will flow in the tubes in a parallel flow. Okay, so when this liquid from that channel or bonnet or header passing through these nozzles, then it will flow through the tubes. Okay, so these are the description of the tubes. So I will show actually the tubes. So here I am showing the tubes of U-tube heat exchanger. So this is one of the type of the heat exchanger. So here if we look at this figure, this is called a tube bundle. So lot of tubes are placed in a cylindrical casing, so it is called a tube bundle. So these tubes is having U shape like this, so it is called a U-tube heat exchanger. The tubes may be like parallel like this only. Okay, we will discuss that matter. So just you kept to notice that this is called a tube bundle. Okay, so here I am showing that these tubes are in a U shape. There may be parallel tubes, that means this part is not there. So there are different type of heat exchangers. We will discuss that later. So this is called a tube bundle. So one fluid is passing through these nozzles, and this is called actually tube sheet, and this fluid is passing through these tubes, then it will return in this direction, and then it will go in this type of the heat exchanger. So these are the construction of the tubes. The next part is the tube pitch and clearance. So for the design of the heat exchangers, there are some terms we have to use to design the heat exchanger. So one is the tube pitch and another is the tube clearance. So what is meant by tube pitch? The shortest center to center distance between the adjacent tubes is called as the tube pitch. So if we look at this figure, so here this is one tube and here there is another tube, and if we take the shortest distance between the two adjacent tube, that means near tube, so this is one tube, this is another tube. If we take this distance, that distance is called pitch. And how you kept minimum pitch? Minimum pitch is 1.25 times the outside diameter of the tube. So suppose this is the outside diameter of the tube, then you have to multiply by 1.25 times, and that distance you have to kept as a tube pitch. So tube pitch is nothing but shortest center to center distance between the adjacent tubes. And there is another definition which is called a clearance. What is meant by clearance? The shortest distance between two tubes is called as a clearance. So if we look at this figure, this is the shortest distance between two tubes. So it is called a clearance. So clearance should not be less than 0.25 times of the outside diameter. So there are some standardization for keeping the clearance. So this should not be 0.25 times the outer diameter of the tubes, less than. So you have to calculate the outer diameter and then multiply by 0.25, and you have to keep this distance. Okay. And minimum clearance between the tubes is 4.76 millimeter. So you have to keep this minimum clearance, and this is the minimum pitch. Then according to this pitch, there are two types of a pitch we can define: square pitch and triangular pitch. So if we look at this figure, this is called a square pitch. So this whole figure is square pitch. That means these tubes are arranged in a square manner or square pitch. So advantage of the square pitch is that it permits external cleaning of the tubes, and it causes the low pressure drop on the shell side fluid. Okay. So what is the advantage? Cleaning of the tubes. So cleaning is necessary in the heat exchanger because sometimes the solids are deposited inside the tubes or outside the tubes. At that time you have to clean the tubes, and low pressure drop is created on the shell side fluid. Okay. So in the square pitch we are having less number of tubes in that heat exchanger. So low pressure drop. So pressure drop is important because the pump calculations are depends upon pressure drop. So therefore the low pressure drop, if you want in a heat exchanger, you have to keep the square pitch. And in another type, that is called a triangular. So you have to arrange the tubes in a triangular manner. So this figure is called a triangular pitch arrangement. So when you can use this arrangement, when you want a larger number of tubes in a given shell diameter, and you have to create a larger turbulence in that heat exchanger, at that time you can use the triangular pitch. So I will show this figure. So this is the actually layout of the triangular pattern and square pattern. So if we look at this, this is actually tube sheet. So these tubes pitch are drilled on a tube sheet. So tube sheet is nothing but the outer part of that heat exchanger in which the tubes are rolled. So here if we look at this figure, so it is a triangular pattern, and if we look at here, it is a square pattern pitch. Okay. So here I will stop this lecture, and today's lecture I had discussed what is meant by different parts of the shell and tube heat exchanger. So that is, first part is the shell, then tubes, then we have discussed how the outside and inside photo of that shell, then tubes, and then tube pitch and clearance. Okay, and remaining part we will discuss in the next lecture. Thanks.